Assalamu alaikum. Bismillahirrahmanirrahim. University of the Punjab. MA MSc Part 1 Annual Examination 2020. Subject Mathematics Old and New Course. Paper 4 Mechanics. Note: attempt any 5 questions in all, selecting at least 2 questions from each section. All questions carry equal marks. Section 1. Question number 1A. If phi x, y, z is equal to xy square z and a is equal to xzi minus xy square j plus yz square k, find partial square over partial z square partial z. Alpha phi. Phi a at the point 2 minus 1 1. B the quantities I, ij, ik, ji, double j, jk, ki, kj, double k. No dot or cross product are called unit dyades. A dyadic is the sum of dyades with suitable coefficients. Give a possible definition of A multiplied by delta B at the point 1, minus 1, 1. For A is equal to xzi minus y square j minus yz square k and B is equal to 2z square I minus xyj plus y3k. Question number 2a. What is divergence theorem? Verify the divergence theorem for A is equal to 4xi minus 2y square j plus x plus z square k taken over the region bounded by x square plus y square is equal to 4 and z is equal to 3. B. Evaluate the integral triple integral v f dv for f is equal to 2xzi minus xj plus y square k, where v is the region bounded by the surfaces x is equal to 0, y is equal to 0, y is equal to 6, z is equal to x square, z is equal to 4. Question number 3a. Verify that if f is equal to 2xy plus z3i plus x square j plus 3xz square k is a conservative force field or not. If so, then find the scalar potential and the work done in moving an object in this field from 1, minus 2, 1 to 3, 1, 4. B. The coordinate transformation between the rectangular coordinates x, y, z and the elliptic cylindrical coordinates u, v, x is given by x is equal to a cos hyperbolic u cos v, y is equal to a sin hyperbolic u sin v, x is equal to z. Find the expression for the unit vector in the elliptic cylindrical coordinates and their times derivative. Question number 4a. The contravariant components of a tensor in rectangular coordinates are yz, 3, 2x plus y. Find its covariant components in a parabolic cylindrical coordinates. B. Given that x is equal to uv cos phi, y is equal to uv sin phi, z is equal to 1 over 2 u square minus v square. The coordinate transformation between the rectangular coordinates x, y, z and the paraboloidal coordinates u, v, phi. Determine the Christoffel symbols of two ideals of this coordinate system. Question number 5a. Define the terms curvilinear coordinates, orthogonal curvilinear coordinates, coordinate curves and coordinate surfaces, covariant basis vectors e1, e2, e3 and contravariant basis vectors capital E1, capital E2, capital E3. Give the explicit relationship between them. B. Let x की power j and x bar की power j be two general curvilinear coordinate systems. Prove that partial square x की power m over partial x की bar j is equal to I j k. Partial x की power m over partial z की power j. Partial z की power n over partial x bar की power j. Partial x की power q over partial z की power n. I M P Q, where I M P Q are the Christoffel symbols of the second kind. Section 2. Question number 6a. For any time dependent vector function at, obtain a relationship between fixed and rotating coordinate systems. Prove that the angular acceleration is the same in the two coordinate systems. B. The moments and products of inertia of a rigid body about the x, y and z axis are I double x is equal to 3, I double y is equal to 10 over 3, I double z is equal to 8 over 3. I x y is equal to 4 over 3, I x z is equal to minus 4 over 3, I y x is equal to 0. Find the principal moments of inertia and the direction of a principal axis. Question number 7a. State and prove parallel axis theorem for the moments and products of inertia for a continuous distribution of mass. B. A rigid body consists of three particles of masses 2, 1, 4 located at 1, -1, 1, 2, 0, 2, -1, 1, 0 respectively. Find the angular momentum of the body if it is rotated about the origin with angular velocity omega is equal to 3I minus 2j plus 4k. Question number 8a. Find the moment of inertia of uniform circular cone of mass capital M, height small h and circular base of radius a about 1, its axis of symmetry, and 2, the diameter of its base. B. Derive Euler's equations of motion of a rigid body rotating relative to a set of coordinate axes coinciding with the principal axis of inertia fixed in the body and establish the constancy of kinetic energy and angular momentum. Write Euler's equation of motion in case the axes are not principal axes. 9a. What are Euler angles? Express the components of angular velocity in terms of Euler angles. B. What is a spinning top? Derive the equations of motion of the spinning top in terms of Euler angles when one of the points on its axis is fixed. Deduce the condition for a sleeping top. University of the Punjab MA-MSc Part 1, Supply-2020 and Annual-2021. Subject Mathematics Old and New Course. Paper 4 Mechanics. Time 3 hours, marks 100. Note: attempt 25 questions in all, selecting at least 2 questions from each section. All questions carry equal marks. Section 1. Question number 1a. If a is equal to 5t square I plus tj minus t3k and b is equal to sin ti minus cos tj, find a. Derivative of d over dt a dot b, b d over dt a cross b, c d over dt a dot a. B. Find a partial square a over partial x square, b partial square a over partial y square, c partial square a over partial x partial y, d partial square a over partial y partial x. For a is equal to cos xyi plus 3xy minus 2xj minus 3x plus 2yk. Question number 2a. Find constants a, b, c so that v is equal to x plus 2y plus azi plus bx minus 3y minus zj plus 4x plus cy plus 2zk is irrotational. Show that v can be expressed as the gradient of a scalar function phi. B. Give a definition of double integral s f dot n ds over a surface S in terms of limit of a sum. Suppose that the surface S has projection R on the xy plane. Show that double integral S f dot n ds is equal to double integral R f dot n dx dy over n dot k mod. Question number 3a. Evaluate double integral S f dot n ds, where f is equal to zi plus xj minus 3y square zk and S is the surface of the cylinder. X square plus y square is equal to 16 included in the first octant between z is equal to 0 and z is equal to 5. B. State and prove Green's theorem in plane. Use Green's theorem to find a. Integral phi c function x dx plus gy dy and b. Integral phi c k y dx plus h x dy, where k, h are constants. Question number 4a. Find the work done in moving a particle in the force field F is equal to 3x square I plus 2xz minus yj plus zk along A, the straight line from 0, 0, 0 to 2, 1, 3. B. The space curve x is equal to 2t square, y is equal to t, z is equal to 4t square minus t, from t is equal to 0 to t is equal to 1. C. The curve defined by x square is equal to 4y, 3x3 is equal to 8z from x is equal to 0 to x is equal to 2. B. Find the scale factors and the volume elements dv in oblate spherical spheroidal coordinate mu, v, phi. X is equal to a cos hyperbolic mu cos v cos phi, y is equal to a cos hyperbolic mu cos v sin phi, z is equal to a sin hyperbolic mu sin v, where mu is a non-negative real number and the angle v belong to minus pi by 2, pi by 2. The azimuthal angle phi can fall everywhere on a full circle, between plus minus pi. Question number 5a. Find the covariant and contravariant components of a tensor in spherical coordinates r, theta, phi. If its covariant components in rectangular components are 2xz, x square y, yz. B. If A R2PQ and B R2PQ are tensors, prove that C R2PQ is equal to A R2PQ plus B R2PQ and D RU2PQ is equal to A R2PQ plus B U2ST are also tensors. What are their covariant and contravariant ranks? Section 2. Question number 6a. A rigid body consists of three particles of masses 2, 1, 4 located at 1, minus 1, 1, 2, 0, 2, minus 1, 1, 0 respectively. Find the angular momentum of the body if it is rotated about the origin with angular velocity w is equal to 3I minus 2j plus 4k. B. Let r dash v and v dash v be respectively the position vector and the velocity of the particle v relative to the center of mass. Prove that the angular momentum omega and total kinetic energy T satisfy the relation A omega is equal to summation V mv r dash v multiplied by v dash v plus m r vector multiplied by v vector. B. T is equal to 1 over 2 summation V mv v dash v का whole square plus 1 over 2 capital M v vector का whole square. Question number 7a. Find the moment of inertia of a disk of radius a and mass m about an axis passing through its center and perpendicular to its plane. B. For a system of n particles, show that the components Lx, Ly and Lz of angular momentum L in terms of moments and products of inertia are Lx is equal to Wxi double x plus Wyi xy plus Wzi xz, Ly W is equal to Wxi xy plus Wyi double y plus Wzi yz and Lz is equal to Wxi xz plus Wyi yz plus Wzi double z. Question number 8a. Find the expression for the kinetic energy of rotation of a rigid body with respect to the principal axis in terms of the Euler angles. Hence, find the result in case I1 is equal to I2. B. The moments and products of inertia of a rigid body about the x, y and z axis are I double x is equal to 3, I double y is equal to 10 over 3, I double z is equal to 8 over 3, I xy is equal to 4 over 3, I xz is equal to minus 4 over 3, Iyz is equal to 0. Find the principal moments of inertia and the directions of principal axis. Find a set of three rotation matrices for Euler angles and express the components of angular velocity in terms of these angles. B. Using Euler's equations of motion for a rigid body having zero external torque, show that I1 omega 1 square plus I2 omega 2 square plus I3 omega 3 square and I1 square omega 1 square plus I2 square omega 2 square plus I3 square omega 3 square are conserved quantities. What do they represent?